So we have X coming in here, and it's dividing into Y and 66. So let's just keep a little gonna keep track of what's going on here. Okay, so we have does everyone agree with this? Because X is making this and it's making this, but this 21 is also involved in this 66. So X is going to be equal to this plus this. So there's no previous knowledge required to make that consideration. Then you notice that 66 is making 59 plus 7. Oh, okay. So that makes sense. So in other words, we're using our intuition as to what is the meaning of all these different things that's happening. It's like looking at a bunch of pipes and just looking at where they divide and where they come back together. So we have now, in our general sense of this, we can imagine this is pulmonary circulation here, and we can imagine this is the right ventricle and this is the left ventricle. And so we see this is going to 59 and 7. Now this 59 comes in here, and we can see that the 59 is going into 10 and 69, or wait, sorry. This is the left ventricle. Here, the blood is leaving the heart at 34, and then 31, and then it's coming here at 10, adding to the 59, producing 69. So 69 is coming down here. And here we have 7 coming around in pulmonary circulation, and this is going to produce Z, and then Z plus Y is going to produce 34. So here the blood is coming up, here 31, and then 10. So the first question is, which of the following likely represents the CVO at W? So we see that over here at 31, and by the way, you see 34 is here, and it drops into 3 and 31, so that's equal to 34. It doesn't matter. We're looking at 31 coming in. This is part of the aorta, leaving the left ventricle. This is actually called the aortic arch, not important. And then we have 31 going in, we have 10 coming down. So we have to imagine that something was lost here. What was lost? W. So W must be 21. So that 21 plus 10 produces the 31. So indeed, the answer to 11 is B. And next, we want to see what is what best approximates the CVO at X. So we've already said that X is going to be equal to Y and 66 minus the 21, because 21 also contributed there. So here we have X, and we can also see that we would need to know what Y is, of course. And to know what Y is, well, here in the left ventricle, 34 is going to be X and Y, X and, sorry, Y and Z will contribute to 34. So Y and Z contribute to 34 before it goes in this direction. So Y we can see here, and Z is 7. So we have 7 plus Y is equal to 24, and that means 34. So that means Y is 27. So this is 45, and this is going to make, well, 72. And so we have the answer for question 12 is 70%, which is A. Any questions about that? Now, you could imagine if you were to believe that you're studying for GAMSAT, and then you read a textbook on the cardiovascular system, but then during the exam, you get something like this. You can see why many students feel after they've studied biology and then they sit the real exam, they feel that what they studied was not reflected in their exam experience. And it's because Acer will come up with many tables, diagrams, graph analysis, which may be unfamiliar. And then they'll see whether or not you can use your reasoning skills to work through it, as many of you have done. Okay, and now for a final dimensional analysis to round things up. So the next question is from a different chapter, chapter 7. I hope that when you look at this calculation later, you will do it yourself, okay? Because when you look at a work solution, it's not as valuable as taking a pencil or pen and doing it long form yourself. There's no calculators permitted on the exam. You need to be quick and efficient with your calculations. So what we're looking for is beats in a lifetime. And so we're going to set up a calculation to get there. So what do we have? We have 70 beats per minute. And now we're going to bring this up because we have beats here, so that's okay, but we have to bring this up until we have this over lifetime. So how do we do that? So we're going to start by converting the minutes. So we know we have 60 minutes in an hour. I know some of you with a math background, you'll do this faster way. No problem. Use the technique you're accustomed to. Then, so I have 60 minutes in 1 hour. I have to go how many hours in a day? And then I have to go how many days in a year? And now I can go 80 years in a lifetime. And this is what dimensional analysis is. It's being very careful with the units, making sure everything cancels out, and then it's just a matter of mathematics. So here I can cancel minutes with minutes, hours with hours, days with days, years with years, and then I end up with beats in a lifetime. So that is the objective. And for the mathematics, you can you can do it many different ways, but one is that you can look at 24 because, okay, I have to underline this. There's going to be many questions on the exam where you have to make a choice as to, can I estimate, and to what degree can I be comfortable with approximations? Because, if you are multiplying 365 by 24 on the real exam, then it's possible, but unlikely, because first check the answer choices. And so generally in a question like this, there's going to be some sort of ACER's going to make sure that the answer choices are sufficiently far apart that you can engage in approximations. If that is not the case, and you have to be very precise, then usually the calculation would be shorter than this. So if you see a calculation like this, look the answer choices. In our case, there are 100 times different in terms of the answer choices. If it's 100 times different, if you change any of these numbers by 10%, 20%, 30%, 40%, what does that have to do with 100 times different? So that's one thing to keep in mind. Oh, so there's a question about the 70 beats per minute. Yes, so it's not that 70 beats. Okay, I'll put it a different way. So in the past, I'm not giving away something, but there used to be a question on the exam for decades. I'm not exaggerating, decades. Students would talk about this exam about the rate of growth of your nails. Yes, you heard that right. Your nails in meters per second. Now, can you imagine, like, how do you start with a number if you don't know how fast your nails are growing? And so, what you're allowed to do is you just make a reasonable approximation. In fact, sometimes Acer will actually put this expression in the question based on a reasonable approximation. And why is this possible? Because if the answers are 100 times apart, does it matter if you choose 70 beats per minute or 100 beats per minute or 150 beats per minute? I hope your heart is not going at 150 beats per minute during the exam. But would it matter? It doesn't even matter, because you would have to choose something absolutely absurd in order to be wondering which is the correct answer choice. So having having a heart rate, yeah, whatever you're comfortable with your heart rate, is still going to work out to the same answer. Okay, so now I'm in the zone of approximation. This 24, I'm going to see is 25 because that's easier to work with. This 365, I'm going to see is 400. Again, it's easier to work with. And remember, 100 times different. It's not as if I'm increasing this by 100 times or even 10 times. I'm increasing it by a relatively small percentage compared to what the answer choices are like. And then we have 4 times 25. That's 100 plus these 2 zeros. And then we have 1, 2, 3 more zeros. 1, 2, 3 more zeros. So I have 1, 2, 3, 4, 5, 6, 7 zeros. So far I have 10 to the 7. And now I'm just left with 7 times 6, which is 42, times 8. So let's see, 1632. So let me do something like that. And then if I'm going to subtract here, I have to add there. So I have 3.2 times 10 to the 9. The answer is B. So I hope I gave you a good standard as to how you can go to analyzing, doing dimensional analysis in biology. Can you imagine? It's called biology, but it's mathematics. And hopefully you see the degree to which this occurs so that you don't spend your time, some people hours, days, weeks, months, studying very, assumed knowledge, which Acer will never really ask. So keep that in mind.